Word embedding is nothing but a process of converting words into numbers. For example, let's say we have an example of a sentence called I ate banana. So here each word is basically segmented into array of numbers. For example, word I is represented by array of three numbers: 0.23, 0.234 and 0.22. Similarly, the word 8 is represented by another array of three numbers, also the value 0.2, 0.123 and 0.78. Similarly, the word banana is represented as array of three numbers: 0.4, 0.3, 0.98. This array of number is also known as a vector, and here, since each array contains three numbers, it is known as a three-dimensional vector, right? So in machine learning, usually you will come across a lot of fancy terms, but which has really simple meaning underneath. So whenever you come across a term called vector, just remember that it's an array of numbers. And whenever you come across a term like an n-dimensional vector, it basically means the size of the array, right? So keep this analogy in mind whenever you come across the terms like this. So that the process, there are various ways of converting these words into numbers, and we will learn about those technologies like word-to-vec, globe embeddings, one-hot encoding, fast takes, BERT, etc. We will learn about that a little bit later. Now you might wonder why represent word as numbers in the first place? What is the advantage? Let's try to understand. So in this particular case, it's a machine that's going to process all of our data, right? So human beings are good at enjoying the aesthetics of the literature or the visual objects. For example, in this particular case, there is an image of an aeroplane. You can see the aeroplane from the childhood. You have learned that by our parents, our teachers have taught us that whenever you see an object like this is called an aeroplane. And you can enjoy the aesthetics of the aeroplane like wings, windows, tails, tires. You can enjoy the aesthetics. You can really understand. But when you ask computers to process this image, computers just need numbers, right? So somehow you have to represent this image as a number. So what we do is we basically take the raw pixel intensity of this image. Let's say this image is of the size of 5 by 5 pixels, right? So for example, what we do in this particular case is this image, we divide this into 2, 3, 4, 5, 1, 2, 3, 4, 5 matrix, and each matrix we take the raw pixel intensity, which ranges from 0 to 255, and then represent it as an array. Okay, so this array of number is the one that we then feed it to the machine, and machine understands this very well. Machine can process this array of numbers very well. So in short, whenever you want machine to process images or a text data, somehow you have to represent it as a number, because machine is really fast, really good, and really scalable in terms of data crunching. It needs numbers because machine also will be using behind the scenes neural network algorithms, and for neural network algorithms to work, we have to represent the data as array of numbers, right? So this is about image. What happens to the text? Let's see a text called Steve Jobs was the CEO of Apple Inc. So we divide this sentence into an array of words like this. So we have got this array of words. So Steve Jobs was CEO of Apple, and then each word then we represent as a 5-dimensional vector. So Steve is represented as 0.23, 0.32, 0.21, 0.12 and 0.12 as a 5-dimensional array. Right? Similarly, each word we represent this as an array of vectors, and this we then feed it to the machine. In turn it feeds to the deep learning algorithms. So in order for our deep learning algorithm and machine to process textual data efficiently, we need to represent word as numbers, and this process is known as word embedding conversion. So this array of numbers over here is known as the word embeddings. Word embeddings is nothing but numerical representation of words. And there are several technologies using which you can represent word embeddings. You can do either one-hot encoding, you can do word-to-vec, you can do fast text, which is a slight variant of word-to-vec, glove, BERT. These are the technologies, and we will briefly learn about each of those technologies in next few